Okay, so this is the part 2 of our linked list. This is a single linked list. We talked about the insertion and general idea of the linked list in the previous one and part 1. Now we're moving on to removing a node. So let's look at what we are doing, and then we can go through these things. So if I have a list, I'm starting with a small list, and then I'm going to go through it. So if I want to remove a node, I have to be careful where the node is. Remember, the biggest concern that we're going to have with the linked list is if you're not careful, we're going to lose our list, the rest of our list. So we're going to be looking at some scenarios, and we're going to go to each scenarios. So to remove after, basically it's going to have a node that's coming in, and we're going to be removing something after that node. So the parameter is going to be a node preceding the one to be deleted, not the one that's going to be deleted, the one before it, because we need to point to that one. Okay, let's check the scenarios that we would have for this removing. So the scenarios would be the first one is we have a list. The one that we want to move is going to be the first one that we want to move, and we have more nodes. Another scenario is we have a first one that we want to remove, but that would be the only one in the list. So we have one object in the list, and we want to remove that object. Another scenario is it is not the first one, and it's not the tail. So it's going to be in the middle. So it's not the tail, it's not the first one, it's going to be in the middle somewhere. Another scenario is going to be it's not the first, but it's going to be the tail. And of course, we would have another scenario that what about if our list is empty? We're going to be checking that all the time. So we're going to accomplish all of these things with this method that's called remove after. And we're going to go through each scenario, and we're going to go through this code to be sure we understand it. So some way of looking at it. So if we have something in the middle that we want to remove, wherever we are, we're going to be pointing to so if I'm here, we're going to be pointing to the next one, and then we're going to update our list. So the first thing we're going to do, we're going to point to so if I want to delete this, so if I want to delete this one, I am looking at my previous one. So I am going to point the next of this one to the other. Again, if I don't keep track of this, I already lost the whole list. But because I have this next updated here, I'm holding on to this next. So let's see how we do this in Python. Okay, so this is the method. We're going to go through it for all 5 scenarios. So be patient with me. We're going to go back and forth and look at all these things. And we're just going to go one at a time. That way we can understand this code. It's the same code, but we're going to be using it for all scenarios. So first we're going to be doing, it's in the first in the list, but it's not the only node in the list. So we have this list. It's going to be the first one that we want to remove. Remember, I need something before my node that I want to remove. So one condition for this method is to receive a node that is null. So if I see in my method that there is a node coming in as a null, I know that I am going to be removing the first element in the list. Okay, so this one is first in the list, but it is not the only one. No. So we're going to be removing this one. So this is what we're going to be removing. So we're going to go through the code. So the first one is going to check to see if it's none. Okay, our current node is actually none. That's what's coming into our, okay. Then we're going to check to see if the head is not none. So the head here is not none, it's pointing to this one. So we want to be sure that we have that. Okay, so in this case, both of these is true. So we're going to go inside of that if statement. So we're going to create a succeeding node that we're going to point it to the self head next. Okay, let's look at what we do. So the head is here. We know it's going to be first element. So what we're going to do, we're going to go to the head, which is pointing to this one. We're going to go to the next of these, and we're going to put it in succeeding node. So this is going to be my succeeding node. This is my current node. This is what I am removing. So by going self head.next, so that's self head, that's pointing to this one. Next is pointing to this one. We're going to be calling that succeeding node. Next, we're going to go, remember, this was for the first element. So we're going to point the head to the succeeding node. All right, so now that this node doesn't have no reference, Python, just like Java, it does have a system to clean up after itself. So it comes in after a while and it's going to clean up that object that's sitting in the memory right now with no reference. So it's got a system to clean it up. So we remove this one. So our head is going to be pointing to this. So that's the way our list going to look like. Because we didn't touch anything on the last or the tail, we didn't have to update the tail. We only had to update the head. Yeah, I don't expect people to get this right away, so we need some time to spend on these things. So what about if I just, it is going to be the first one, but I have only one object in there. Okay, that's the scenario. I have a linked list with one object. So I have to be careful about some of the things I was doing it on the previous one. So we're going to come down here. Our current node is empty. There's null. But self head is not none. Okay, so we are okay with this. So we're going to go to the same if statement. Now, it says succeeding node is going to be self.head.next. This is going to be self.head.next is going to be pointing to null. So my succeeding node is going to be pointing to the null. Now, we're going to be pointing the head to succeeding node, which at this time is going to be null. We're going to check to see if our succeeding node is none or null. That's where we are right now. If that's the case, we have to update the tail as well. So we're going to end up with an empty linked list. That's going to be pointing, the head and the tail is going to be pointing at null or none. Okay, the next scenario, it's not tail. So we looked at the first one, we're going to be looking at the last one. So if it's not tail, we're going to get a current node that has a value. Remember, if it's at first, it doesn't have no value, but if it's not the first, it's going to have a value in it. So let's look at our list again. So the current node is going to be pointing to node A. That's what's coming into us as a parameter. So this one, we are calling it with node A. So we're calling this method with node A. So my current is pointing to node A, and that means the next one is going to be deleted. Now, so we're checking to see if the node is none. The node has something, the current node has something in it. So this is not true. We're going to go to the next if statement that says current node dot next is none. So current node dot next is not none. Remember, it's at the end, it would be a none. So it's not none. That means it's in the middle of the list. So what do? We're going to update our succeeding node to go to the current node dot next dot next. So the succeed is going to go to this one dot next dot next. That's the way it's going to know where it is. So we have the node before it, and then we have the node after it. Now we can update them. So the current one is going to be pointing to the successor, succeeding. So this one is going to be pointing to this one. And the next one is checking to see if the succeeding node is none, which is not. So we are not going to do the next element. So again, by this operation, this object has been left out in the memory, and the Python is going to come in and clean it up later. So at this time, this is sitting in the memory with no reference to it. Okay, so we're going to be ending up with the list like this. The B has been removed. The next one is, it is not the first one, but it's going to be the tail. Okay, let's go through the same thing. So I am receiving node B. So my current is going to be pointing to node B. That's where the current is coming in as a current node to our method. So we're going to check it to see if it's none. Of course, it is not none, so we have something in it. So we're going to go to the next if statement, and we're checking for the current node dot next is not none. So this is a current node, and the next is not none. Okay, so we're going to go inside of this. So we're going to use succeeding node equal current node dot next dot next. So this is current node. Dot next is going to come here. That's the next. So my succeeding node is going to be pointing to the node. All right. So we're going to be updating our current node. So this current node is going to be pointing to succeeding, which in this case is going to be node. Now, remember what we're doing right now is we are removing this node over here. So if we are removing this node, our tail is not going to be pointing to anything because this is going to be gone. So that's why we are going to be checking. So if it is none, meaning that this is pointing to the end, we have to update our tail. The tail is going to be, so the tail is going to be updated to the current node. Remember, current node is going to be node B. So we're going to be pointing to this one. So the tail is pointing to this. The next of the node B is going to be pointing to the null. And this one is going to be left in the memory for it to be cleaned up afterward. So we're going to end up with the list like this. The last one that we want to check is if the list is empty. So when we're writing the code for these things, we have to check all the conditions. Otherwise, it's not going to work. So we have to spend time to figure these things out. All right, so we have an empty list. That means I have a list that doesn't have any head, doesn't have any tail. We just created this object and it's empty, or we remove all the elements from it and it's empty. So what do we do now? We're going to use the same function for the empty one. Let's go over it to see what happens. So it's checking to see if the node is none. Yes, it is none. But is self head not none? No, self head is none. So we cannot use this if statement. It's going to go to the next if statement. It's checking to see if current node dot next is not none. Current node is null. So it is, this one is not correct neither. So it's going to fall through. Basically, it's not going to do anything. It's not going to try to remove anything. Remember, if I try to remove something that's not in the memory, then we're going to have some problems. Okay, so this is a 5 scenarios for removing by using the same method, removing element from the linked list. The next one, I'm going to be talking about the efficiency of the linked list. So I'm going to stop right here. I'm going to go to the part 3 for the next one.